Welcome to this new YouTube series about the coupling of Python and SimulationX. Um, in this introduction, I want to motivate why we want to do it. And you may know SimulationX as your tool of choice for modeling and simulation of dynamic systems, making use of the Modelica language, making use of the many pre-built libraries inside SimulationX for various physical domains, and Python, a very powerful scripting language with lots of documentation in the web, lots of pre-built packages that are available, easily installable via PyPy or other tools. And it's a really powerful scripting language. And together they open up practical new workflows which improve your efficiency, which can add new features that you are missing. And I will give some small examples on this. So the main motivation is either to save time for repetitive tasks that you need to do quite often, and you would need to do them manually, and this is exhaustive, it's error prone, and of course automation would help here on this. And so with Python you can automate, for example, pre-processing, post-processing of data. It can run repeated studies, so parameter variance optimization, which will be the example here in this motivation. And so you reduce the clicking and the possible mistakes you make, and of course save time. Another motivation why to use Python is possibly to extend capabilities. So there may be features missing in SimulationX, either already with respect to pre and post processing of data, that you get data quite often in a shape that does not immediately fit into SimulationX without any changes, or vice versa, that you have results that are calculated in SimulationX where you need to extract some features for your reports, or even need to create reports in a special shape. Yeah, or anything else that you can think of. And so either you wait until the feature is built in SimulationX, or you may also try, if you have an idea how to do it in Python, you could use Python to implement that. So it's quite a good way to extend SimulationX to your specific needs. The example here I have opened, it's a sample model, and it's the model of an aileron. It's in our sample repository, and it includes it's a multi-domain model with control elements, kind of an overall control with some state machine, the control logic, so to say. Then we have the hydraulic actuators, the hydraulic drives, and the multi-body model of the aileron. You see also here a 3D view of this element, and I can run the simulation. So it was quite quick. I run the animation. You can see what happens. So it's controlling these hydraulic drives to control or to move the aileron into the desired position. And we have, that's the kinematics model behind. Then we have hydraulic part is inside here. So really multi-domain model. And here we want to optimize the controller settings for the ECU of the hydraulic drive. And therefore, there is in addition some feature extraction already included in the model, that the position of the aileron is within some certain limits, and the boundaries of these limits are narrowing down with simulation time or with actuation time. And so from this, we formulate some quadratic error, which is a good performance criteria. And then this is fed into this block. And this block is mainly just for holding the parameters. So we need to place somewhere the criteria. We need to say which parameters it shall change. We may want to give some boundaries in which the parameters must lie. And then we run the script with this button. So it's kind of holding the arguments for the script. So you see that the integration of the Python script in SimulationX can be very nicely, so that you do not even notice that much that you are working with a script behind. And what the script then does is running simulations, changing parameters, reading back the results to check the criteria, and then changing the parameters and running the simulation again until we reach a minimum with some tolerance for our criteria. And it's doing that, all of that automatically, of course. And what we use behind the scenes is actually the SciPy minimize. So these methods are available and selectable via this element here. So it's kind of wrapping what Python can already do. And this is how you could also do it. So you could make use of the simulation interface, SimulationX graphical user interface to parameterize your scripts. But you do not need to. So you can write your own graphical user interface. You can use Jupyter notebooks. You can do it as you want. And you see here, that's a quite good example. SimulationX provides the model and the results, and Python manages all the repeated automation steps and even the optimization algorithm to achieve a good control. And that's quite fast in comparison to a trial and error approach, of course. A second example that I want to give is reporting. You see here an example HTML report that was also generated with Python and Jinja and Plotly. There is already a print preview available in SimulationX, which generates either HTML or PDF, which looks quite similar. But of course, when you use Python, you have it's much more adaptable. Then you can do whatever you want. You can include pre and post processing steps again, bring it to exactly your shape that you need. So you have a high level of flexibility. And again, what we use here was just Python, Plotly, and Jinja. Yeah, so that's just another example for the application for a good reason to couple SimulationX and Python. Yes, so that should be all for the motivation. Then thank you for watching. In the next video, I will show how SimulationX is configured and how the Python is integrated. Thanks for watching.